Welcome everyone to this Leaders Workshop, whose topic this year is Open Science and Open Publishing. And we have what I think is a very exciting program with 3 sessions. The first one by Roberto di Cosmo. We are solving some last-minute problems. And then after lunch, we will have a panel with breakout sessions that will run in parallel. And we will close the day with a video conference connection to the US, where the Assistant Director of the NSF for Open Science and Open Publishing, Ardo Lopia, will tell us how they manage these things in the United States, which probably is something that we can learn a few things from. And well, I have to thank Carl, which is my co-chair of the workshop, for all the good advices and all the work. And we hope that you enjoy this workshop, which I'm sure you will. Carl, I don't know if you want to say a few words.
Sure. Thank you, Manuel. It's been an interesting journey in terms of solving all the challenges of bringing people here and lining them up for you in open science and all the impacts around that, in terms of careers, in terms of publishing culture, in terms of reviewing, but also for leaders, as us, for example, in departments or even in faculties, how we should deal with the open science challenges, how we should transform that into the career advice to students and colleagues, but also to performance reviews and performance appraisals of our faculty. So these are challenges which are on the table, which have not been solved in a sense, but they are to be discussed. And for that, we are seeking very different perspectives as inputs for us as a community, how to move on with this great opportunity. Many of us have signed the DORA Declaration of Open Research Access, yes. And I think we have all been starting on this way, on this path, how to implement that in hiring committees and beyond, but also in a way to support our young careers.
Could you take your mask off so that we can understand it better?
Okay, sure. Do you want me to repeat the last 75 minutes? So make it short. Welcome to be here. I'm happy, and thank you, Manuel, for doing such a great job. You've been a tremendous partner in this, and I look very much forward to the sessions. And with that, I leave it to the next more important speaker, Roberto, and I let you introduce him.
So while some technical difficulties are being solved, let me introduce Roberto for those of you who don't know him. So Roberto is an alumnus of a Scuola Normale Superiore di Pisa, and he has a PhD in computer science from the University of Pisa. He was an associate professor for almost a decade at the École Normale Supérieure de Paris, and in 1999 he became a full professor at the University Paris Diderot, where he was head of doctoral studies for computer science for a number of years. He's also the president of the Board of Trustees and the president of the Scientific Advisory Board of the India Software Institute from Madrid. And he's a member of the National Committee for Open Science in France, and he's currently on leave at INRIA. He has researched on a number of topics, including functional programming, parallel and distributed programming, semantics, type systems, writing, linear logic, but more recently, by the new problems posed by open source software and in general by open science, with a particular analysis that he will tell us about on the static analysis of a large corpus of software. He has published over 20 journal papers and more than 50 international conference papers. And he created the international consortium Mancusi with a more than €4 million budget, which put together 10 partners working on improving the quality of software packages. And he's an advocate for open source since a long time ago, and this is how I got to know him. And he has contributed to the adoption of open source with books, for example, with a bestseller, Hijacking the World, with seminars, articles, and with, for example, with the free software thematic group of Systemic, which helped to develop and fund more than 50 open source projects with an amount of funding of about 200 million euros. So he was from 2019 to 2018, the director of IRIL, which is a research structure dedicated to free and open source software. And more importantly for us today, in 2015, he created and started directing Software Heritage. Software Heritage is an amazing initiative to build a universal archive of all the source code that is publicly available. And this is done in partnership with a number of industrial partners and academic partners, and with the support and backup of the UNESCO. So, Roberto, the floor is yours.
It's a pleasure to be with you here today. And I have the honor and the charge to open this discussion on open science. So the title of the presentation is Towards a Software Pillar of Open Science. So I would like to take this occasion to highlight different points that I think are very important for where we are today. So just thanks for the introduction, Manuel. Just to remind very briefly why I'm here to talk to you today. I spent over 30 years of my life doing the same job we are all doing, okay? Teaching, doing research, trying to educate the next generation of researchers and engineers in this beautiful discipline, which is informatics, right? But then I spent over a quarter of a century today to actually be an advocate for open source when it was a difficult moment to actually advocate open source. Now it is mainstream. And almost 10 years ago, you see I have some white beard or gray beard, as you want, so that you spend time at this age in life to create structure for the common good. So let's start this presentation by talking about open science. Okay? Open science is a movement that is taking a lot of attention now, but if you look for a definition of open science, it is not so clear, right? There are so many things, so many moving parts inside open science. So I digged around a little bit, and the best definition I could find is this one, which is from the National Plan for Open Science in France, so the second edition that was published in this July last year. So the definition of open science here would be to be an unhindered dissemination of results, methods, and products from scientific research. And this unhindered dissemination comes thanks to the opportunity provided by this recent digital progress that allows us to share publication and as much as possible data, source, and research in a very easy, cheap, economic, unfettered way. Okay, so this is open science globally. But why should we care about doing open science? So here you can look at what Jean-Éric Paquet, who was a general director of research and innovation in Europe here, wrote in the introduction on a document on the objective of open science. So the idea is that we want to have all this unfettered dissemination of knowledge because this allows us to increase the scientific quality of what you're doing, the pace of discovery, and the technological development, but last and not least, especially in this period, global trust of society into the result of science. Okay? Transparency that comes with the unfair dissemination of research results helps make public policies better accepted when they are based on scientific results that everybody can verify. El anfitrión desea que usted reactive su audio. Cancelar? Okay. Okay, moving forward. And then now it is not moving anymore. So, okay, going here. And then if you look at what Maria Gabriel, who is the EU Commissioner for Research today, and a bunch of other things, the COVID situation we have been through over this year and a half, almost 2 years now, is that it has shown that international cooperation and better access to the result of research are key to actually face successfully the challenges that can come from anywhere. I mean, this virus is not an enemy you can sit down, discuss with, and make an agreement. The only thing you can do is try to fight and win the battle against this kind of virus, and you have seen what happened. I mean, all of a sudden, access to publication about COVID has been opened up to everybody. Well, not as much as it was necessary, right? But at least sufficiently to push forward the development of vaccines and remedies against this kind of challenge. And what Maria Gabriel says, and this is so important, is that actually no nation, no country can tackle any of these challenges alone. So we need also to resist the temptation to close down, okay, to only look inwards. We need to foster better collaboration. And then I found also a citation by Yuval Noah Harari, who is the author of the Sapiens, this best-selling book about the history of mankind, where he actually says, you see, the real antidote to the pandemics we are living today is actually scientific knowledge and global cooperation. Okay, so I think in these 4 citations, you get an idea of why open science is so important today and what people is expecting from us when looking at working in science in this movement about open science. Of course, there are so many other moving parts, okay, open evaluation, career evaluation, etc. We will discuss about all this together if you want. But these are the main societal, political drivers of open science today. We need to take them into account. Now, that being said, I mean, these are global principles, right? But then, what are the pillars of open science? There are a couple which are very well known. One pillar of open science is open access, which is not new, right? There is a long story behind open access, which is actually an unfinished, painful, complex story. It starts in the 1900s with a strange, maybe not even really well thought out strategy on our side as scientists to actually give out exclusive rights about our production, our scientific production to scientific publishers. Well, this was done before the internet in a situation where actually there was a marriage of confidence there because we needed to have somebody helping us to spread knowledge as fast as possible, and scientific publishers were actually really helping us and giving out exclusive rights about our work. Well, we didn't care because our goal was just to have this as soon as possible in the library, in the university, on the other side of the planet. They did the job, and we didn't actually care a lot about giving out the rights or not. But then, let me say, there were a couple of exceptions to this not well thought out strategy about copyright. One is in the US. In the US, everything developed under federal funds, with federal funds, was devoid of copyright, was in the public domain from day one, okay? And if you look in the UK, you have the UK Crown copyright, so people working, civil servants, everything produced by civil servants, the copyright goes to the Crown and cannot be given to private publishers, right? So these were the only 2 notable exceptions. Then in the 1990s, we have what we actually created. So the internet, the web, and then tools like Arxiv that actually show that this marriage of confidence was just a marriage of confidence, not more. Now you have different interests. When you discover that you can publish your paper by putting it on a web server and it is accessible to the world in just in a couple of minutes, why should you wait months for having it printed and disseminated around? And why should you listen to people telling you that you cannot put your published work or accepted papers on a web page? This is what we were told, you remember, years ago. And so then in the 2000s, you have people starting to notice that there's something rotten and we needed to fix it. And so this is the age of declaration. You remember the Budapest Declaration, the Berlin Declaration on Open Access, and many other things like this. And then in the 2010s, you have actions. Some actions that you could consider unlawful, like, for example, Sci-Hub. I mean, basically pirating all these papers from around the world, making them available. And then actions which are more in the frame of the law, for example, Plan S, this big Plan S you have all heard about on publications, which is led by the European Commission. and pushing to transformative agreements, which is not an easy thing. By the way, the slides here will be available, are actually already online, and everything which is in blue is a link. So you can click on the link and you can get actually the relevant documents. We are academics, right? So it's not just opinion. You can click on the link and you can get access to the supporting element for what I'm stating here. And if you're curious to see what I think about this particular pillar of open science, which is open access, there is a viewpoint I published in 2005 and a blog post in 2020 on SIG plan. I will not repeat all that here. But again, open access is a long, painful, and unfinished story. The second pillar of open science is open data. And open data is, surprisingly, a much less controversial history. It's much smoother path. So basically it starts with this International Geophysical Year in the 50s, where the people decided all this data should be made available for researchers. And then after that, you have recommendations from OECD on publicly funded research data, the original ones in 2006, and the new one have been published just a few months ago, in 2021. And then also this has become very popular in 2016 under this acronym of FAIR, Findable, Accessible, Interoperable, Reusable about data, which is actually very spread around. My personal opinion is that, okay, it's important to have fair data, but the focus is really on having metadata, not much on being open. So there is kind of, I prefer the original presentation, right? So instead of focusing just on metadata. But the key story here is that you have two pillars that everybody knows about open science. One is publications, the other is data. Publication, a long story which is not finished. We are still fighting to get out of the mistake we made decades ago. For data, moving forward rather reasonably. And the point is, there is a long overlooked third pillar of open science, which comes from our field. Okay, and this is actually software. Software has been long overlooked. I mean, I have tons of stories I could tell you. I'm sure you have yours. Okay, when I was a student in Pisa in the 80s, I mean, the opinion you had from other people. My professors in physics looked at me and told me, okay, so you are a bad physicist, but you have a computer. And my professor in mathematics looked at me and said, you are not such a good mathematician, but you have a computer. So, come on. No, it's a different science. It's another science. It is a noble science, okay, which is actually changing the world. Okay, so you should recognize it. And now people are starting to notice. Okay, this citation here in Nature, 2014, you have this, they did the studies of the top 100, the most influential papers in Nature, which is not exactly the first place where I go publish. And the large majority were papers describing software which has become necessary for making progress in those fields, which is not informatics. Then later on, in an event we organized in Paris for this National Committee of Open Science, we had Christine Borgman that did a lot of studies about the importance of software in data. And she has this nice phrase. I mean, sometimes if you do not have the software you use to produce or treat the data, you don't even have the data. So people are starting to notice this. And so here we really need to take care about the missing pillar of open science, which is actually software. And so you have this triptych here: data, articles, and software. And the links are very important. I need to have access freely to a paper that says, we did this analysis on this data and we found the result, and the result happens to be 42. But if I do not have the data, I cannot verify the result. I cannot do my own analysis on the data. But if I do not have the software, I do not know how this data has been transformed and modified. Okay, you really need all of these three things. And the other point about software, which is important, is that if you look at software, it is kind of proteiform in research, because it can be a tool, and for many other disciplines and research fields, it's just a tool. But for us, it can also be the outcome of research. Okay, it is a result of research activity. And in other fields, it is even the subject of research, or the object of research. Is you do research on software. Okay, it has multiple facets in research. It's very important. I'm trying to move to the point where I want to justify the fact that we are missing one pillar in open science. This pillar in open science is software, that have multiple facets in research. And also, one point that I think is extremely important is for reproducibility, we need to keep track of all the software source code we use and also the precise version of the source code which is used for developing results, experiments, etc. Okay? Now, when people talk about software, this is one of our difficulties in our field. Everybody is using software. They don't even notice. Okay? They're using the phones, in the communication, in transport, in entertainment, whatever. They talk about apps or something like this, but they do not actually understand what software is. And the worst thing is that if understanding what software is complicated, understanding the software doesn't come out of the blue, but is actually developed by people that write software in form of source code, is still one step forward for our fellow citizens to understand. So I would like to go back to the idea that not only software is important, but in particular the source code of software is important, because it is in the source code that we found the knowledge, the scientific, technical, organizational knowledge that we are slowly embodying in all these software that we are using. When I was a student many years ago, I was using a book by Harold Abelson, an MIT professor, and I think some of you know this book, Structural Interpretation of Computer Programs. In the introduction to the first edition, he had this beautiful statement that says that programs must be written for people to read and only incidentally for machines to execute. And this is also if you remember Donald Knuth, I remember he had a similar phrase once. He was saying, you know, the programming is the art of telling another human being what I want the computer to do. Okay, and this for us is very clear. For many of the other people around us, it is not so clear because there was not so much software source code available many years ago. But today, after decades of open source movements and free software movements, we have an incredible amount of open source software available for us. For example, you can find beautiful fragments of the source code of the Apollo 11 control system. You remember Apollo 11 is the effort of mankind of putting a man on the moon, and what we should remind is that if we manage to put a man in the moon, it is thanks to a lady, Margaret Hamilton, that actually directed a whole team of programmers that produced the 60,000 lines of code that were embarked in the first flying interplanetary embedded computer system of history. Okay. And if you look at this piece of software, you will see that on the left side, you have the mnemonic for the assembly code. Okay, this goes to the machine when it is compiled. But on the right, you see after the number sign, you see all these comments in English basically saying what is going on in the software. And these comments are messages, are exactly the messages from one man, from one human to another human to tell him or her, look, this is what is going to happen when you run this piece of code, what I expect to see happening. When this is in the 60s, you can think that these kind of comments were justified by the fact that the programming language were not evolved enough, but it is not the case. If you look later on, like this is more recent. In the 90s, it's a fragment of the source code of the Quake 3 Arena game, which is the ancestor of this Call of Duty-like games that our kids may spend too much time on right now today. And this is a beautiful piece of code, is a mythical routine for computing 1 over square root of x without using floating point processors, which are too slow in the 90s, using beautiful tricks that use binary representation of floating point number, some mathematics, and some other tricks in programming. So I will not spend time on this because it will require an afternoon to go through this particular part of the code. But here you see again, there are comments all over the place, and the name of the variables and the name of the function carry information which is meaningless for a machine, but which is fully meaningful for us. And that's the reason why we want to keep source code at hand. Because as Len Schuster, who was a board director of the Computer History Museum, once said in a beautiful paper 2006, the source code, access to a source code, provides us with a view into the mind of the designer. So source code is a precious part of our knowledge. It is one of the pillars of this open science movement. And now let me take a couple of minutes, if I may, to push more this idea that source code is special, and in particular, it is not just data. Because in the last year, I spent an incredible amount of time trying to discuss with people in different communities, in different areas, trying to push about the importance of preserving software and preserving software source code in particular. And very often, I see or hear people telling me, but look, software is just a sequence of bits. A sequence of bits is a piece of data. We already have infrastructure for preserving data, so why do we need anything special about software? Okay, so you need to have arguments to tell them, no, it is not just a sequence of bits. Okay, yes, it is a sequence of bits, but not just like the others. And so here are some reasons for telling them actually source code is special and not just data. First, software actually evolves over time. A project may last decades, and actually access to the development history of software is very important. This is why we use version control system today. You are not going to read 1 million lines of code from start to end just like this. Okay, you need to know why a line of code is in there. The other, that the software can be extremely complex in different ways. You have big pieces of software, millions of lines of code, which are actually developed over a long time, or it can be complex for other reasons, because you rely on a complex network of components and dependencies that you need to pull in as soon as you just type a couple of commands in your interpreter. Here, for example, this picture here, this small picture, is a visualization of all the components and dependencies you pull in as soon as you launch a Python interpreter and type import matplotlib. It is the first step to do some drawings like this one. And also there are sophisticated developer communities. It is not just technical, it is also a human endeavor. There are many sides on the human side, the people who actually come up with the algorithm, the design of the software, the test, the documentation, coding, etc. It's a very complex object. It cannot be dumbed down and treated just as a bunch of bits that you need to put in a bucket somewhere with an identifier stuck on it. Okay. Well, all this was actually well taken into account in an expert meeting that took place at UNESCO in 2008, November 2018. The call was published in 2019, where 40 international experts were invited to participate to this meeting in Paris. Some are part of our network today. And this ended up with this call published in February 2019, which is a typical UNESCO-style call, but I selected one of the parts of this call that I suggest to read just for a second. So the expert panel called on member states, on UNESCO, on different actors to promote software development as a valuable research activity, and research software as a key enabler for open science and open research, sharing good practices and recognizing the careers of academics, their contribution to high-quality software development in all their forms. Okay, so this is written in this call, which is published. It is, you can access it by this link. It can be signed. It actually was signed, if I'm right, Enrico, by Informatics Europe too. So this was basically an introduction, a little perturbed introduction to get to this point, but we'll see if I can move forward. Now we want to build this pillar of open science. First step is assessing the needs. Let's see if we can agree on the needs we have. Depending on where we are, who we are, and what hat we have on our head in our particular moment, the needs we face may be different. There are many. For example, if you're just a researcher, and you are doing your research, you are publishing articles, you are doing software development, etc. What you need is a place where you can take the source code of the software you have developed, archive it and reference in such a way that you are sure that another scholar that will read that paper and will need to access the particular source code later on, and this other scholar can be me in 2 weeks or 10 years, okay? I need to access my own work back on. I know where I find it, okay? An archive and a reference system to get there. Then in the way of finding useful software for me, the other thing that I would like is if somebody finds my software and uses it, I would really like to be credited with the work. I mean, give me credit for what I did. And finally, also, if I look at papers of our authors, I want to test what they did, not just to verify the result because I distrust it, but because I can adapt their software, their approach to build better results. Okay, so these are basic needs. And you see it's archival, reference, getting credit, finding the software, the ability to reproduce. These are basic needs. Then if you put your team director or lab director hat on, you have extra needs. You have many researchers working with you or for you, and you need to track this contribution because you need to write reports, you need to have a web page publishing what you're producing in different ways. And if you are a research organization, you need to know what are your software assets because there are many, many questions that you need to answer. For example, you have a technology transfer department, and they want to know what kind of software products can be the basis of an agreement with a company. You may want to show to your funders, can be a Ministry of Research, other kind of funders, what is the impact of your research. I mean, we produced this particular software which is very useful, was helpful for this or that application, your impact matrix. But also inside your organization, you need to have a strategy for funding. If you have 10,000 people knocking on your door, you happen to be the rector of a university, and you only have the ability to fund 1,000 of them, how do you choose which one you want to fund? And also for career evaluation. I mean, we were so much used to only count papers, but there are contributions which are softer, and they should count towards evolution in a career. And so we should be able to track all this. So you see, when you have these kind of needs, what is at stake, basically, and I put it in order of difficulty, is the ability to actually have an archive. We need an archive, we archive software. That should not be that complicated, right? But it can be. You have a schema for referencing precisely the version we are using for our work, a way of describing the software to make it easier to find, and the way of giving credit to authors. Okay, this is 4 key things that you need. But there is more than that, because if you go beyond these 4 things for which we have strategy for answering, there is also policy issues. There are policy frameworks for disseminating, using, reusing, evaluation, and recognition of what we do. Sustainability. Developing software is more complex than just publishing papers. When you start a software project that may last decades, then you need to take into account the need of having engineers or researchers taking care of this, how you make it sustainable over time. And this requires a professional approach to this, not just getting money here and there whenever you are in a difficulty. Okay. Then technology transfer, industry collaboration, how you actually do it in an efficient way. And we also need some advanced technologies and tools to improve the quality of the software which is developed in research, which is not so easy to do. Now, I would like to start, this was supposed to be started a half an hour ago, but I mean, I will try to shrink it a bit. There are two places here. I will try to address together with you phase 1, these 4 actionable things: archive, reference, describe, and cite. I'm giving credit. And then we move to the more policy-related issue. There are good news on both of these phases. So phase 1. So if we focus on this archive, reference, describe, and cite, I think, first of all, what is the state of the art today in our world? Okay, so the state of the art today is not ideal. Okay, even in computer science, actually, we are the expert in software, right? So we should be giving the example to the other discipline. Well, the example is not yet there. I mean, some 15 years ago already in ECSSS, which is a leading conference in software engineering, there were papers that look at the literature and noticed that there were no replication studies, which was not necessarily a good thing. Then Carlo Ghezzi had another paper in analyzing ACM-TOSM in 2001, 2006, and he discovered there were 60% of papers were mentioning tools, and only 20% were actually installable. You could find them. Later on, Christian Kolber in 2015, I think, he carried over reproducibility studies on over 600 papers in the leading conference and journals, and he ended up discovering that only 40% of the software associated to this article was installable. This means 60% was not even installable. We are not even speaking about reproducibility. It is just, can I get the source code, compile it, and run it on my machine? So we are really not there, right? And the remarkable fact is that if you look at the main reasons of these failures, is that the source code, or the right version of the source code for this software, is no longer available. And there are two reasons why it may be not available. One is a policy issue. It is not available because I am not allowed to share the source code of my software. It can be a decision like this. Or technical reason, because simply there were no infrastructure to archive and make it referenceable. So let's start from this part. Let's start from the infrastructure, because the first part, which is policy, is the second phase. So you can ask yourself, where is the source code of software today? Well, typically it can be found on collaborative development platforms. Our students today use GitHub all over the place. When I was younger, I was using SourceForge, which is still there, I can tell you, but maybe nobody remembers. These are places where you can go and work on a piece of software collaboratively with other people. Then you have distribution platform. These are places where a given stable version, a piece of software, is put there to be distributed, for example, in a package management system. And finally, you have archives. Archives are places which are not used to develop software, which are not the first place where you go to actually download a piece of software, but they are there to make sure that a piece of software that enters the archive stays into the archives and will stay there forever. So you can get it in the long time. Unfortunately, a lot of our colleagues and our students still do not make the distinction between the mission of these three different objects here. We tend to think that collaborative platforms are archives. They are not. Okay, so in 2015, two big collaborative platforms, Google Code and Guitars.org, were shut down, and this endangered almost 1 million software projects that were hosted there. Okay, and when they were shut down, this generated broken links in the web of knowledge, including in articles I wrote in 2012 and 2000, etc. They were mentioning software that was put on these platforms. 2019, last summer, so Bitbucket, another platform, again announced that for business reasons, they were removing support for a particular version control system, which is called Mercurial. So this endangered 250,000 of research projects, of software projects, okay, including a lot of research software. And just a couple of weeks ago, just to look at my own institution at INRIA phased out a Forge, a collaborative development platform, which was an old platform. And despite all the effort of doing things the best way you can do, there was a link to that Forge to download the source code of a particular component, which is essential for the package manager of the OCaml programming system. So the whole OCaml ecosystem was down for a few days, with people scrambling to see how you can put back the software in the right place. So you see, this is happening every day today. Okay. So the bottom line, if you want to address this archival issue, you need an archive. You cannot take something which is not an archive and use it as an archive. You need an archive, and you need a universal archive that takes everything. And the good news is that we have one. So this is the software heritage project that Manuel was mentioning before. We started this, the idea is 7 years old, and this year we are celebrating the 5th anniversary of the public announcement of the project. The mission is actually to collect, preserve, and share the source code of all software that is publicly available. It is building a reference catalog that no matter where software is, you will find it referenced in software heritage. It is an archive, so that comes in, will stay there. So good news, Gitorius, Google Code, Bitbucket, everything that was endangered, it is safely archived already, so it is not lost, you can find it. Actually, I found the source code of a paper of mine in 2012 by looking into software heritage, because I didn't have a copy of it any longer, but it was in the archive. And finally, it is the first brick in research infrastructure that will enable us to actually explore the galaxy of software development in the future. How does it help us address these 4 ARDC issues? Well, for archiving, okay, we are basically going out there and automatically tracking and archiving source code, which is in a very broad panel of different source code development platforms. And we track all this, and we convert all the version control system in a uniform data structure, which is a Merkle tree, but I do not have time to go through this now. So the good news is that maybe that your research software or the research software your students or your researcher, maybe it is already there, okay? Because we crawl it automatically. But it is not sure, because we do not have yet enough resources to actually track everything in the world. So what we did is to actually create a mechanism which is called Save Code Now. You go to save.softwareedge.org, and there you can enter the URL of a version control system you want to archive it. It is archived in a couple of minutes automatically. So you can trigger archival everything which is interesting to you. And then there is a third way, which is a deposit mechanism that allows actually to deposit explicitly something in the archive, and we use it in partnership with open access portals, where you can deposit research software with curated metadata. So just to give you an idea, I mean, again, when Bitbucket was closed down, we scrambled to archive it. And this comes up. This tweet here that you can find in the slide by clicking on the link is by a researcher in astrophysics that in last summer discovered that a piece of software associated to their article, to his article, had disappeared because it was on Bitbucket, and say, oh, I lost everything. And then all of a sudden he found out that it was archived in software edge. And so this tweet, and I swear I do not know him, and we didn't pay him. I mean, the tweet is just saying, thanks a lot for saving this, because this saved my day. You see? So this is the importance of actually automatically archiving as much as possible things too. For reference, what we do, we provide intrinsic identifiers, cryptographic identifiers, that allow to identify exactly every single piece of software that is developed and archived there. So there is a possibility of having also qualifiers for the identifiers here that can provide you links in the context. This is an emerging standard. It is included in SPDX 2.2, which is maintained by the Linux Foundation. The prefix is registered with IANA, and you have properties in Wikidata. Then again, with all this disruption in the presentation, I do not have time to give you the demo now. But click on the links, and you will see how using this identifier you can go to exactly the fragment of code which is interest for you. And this is a game changer in the way we write papers, right? We also try to lend a hand on something which is not our core business. I mean, better description of source code using a standard which is called code meta, better way of giving credit to software. So last year I took some time to write down finally BibLaTeX style for citing software, so you can use it, and it has full support for all these kinds of identifiers, etc. And this would be the time where I give you a demo of all this. But I do not have the time to do it, because otherwise we don't have time for the discussion. So let me move to the second part. But this page here which is for the demo, all the blue links bring you to the places I wanted to show you. So if you download the slides, you will be able to actually play with the archive directly. So there is a growing adoption of this archive in academia right now. So we have a connection with the National Access Portal, Open Access Portal in France, where researchers in France are encouraged now to deposit research software to get a reference. We are connected with the SW Math initiative that tracks all relevant software for mathematics. It is connected to a central block. We are trying to help, I mean, we cannot talk with 10,000 different journals around the world, but we picked a few to play with them and see how archival or software associated to research article can be done efficiently. So you have this journal in image processing, this is in life sciences, this is in mechanics, and they are all using the archive to archive the software and reference it properly. And more recently, there are policy news on which I will spend more time in the second part that include support for this universal archive to be used to foster to reach objective open science. Software Asia is not a project. Okay, it is a long-term initiative. So if you want to start something like this, you do not go for a European project. European project is money at time T, then T plus 3 years, you run scrambling to find money for the next project. This is not the approach for a long-term initiative, okay? So what we do is we are building an international foundation in partnership with UNESCO and support with different learning society and organization. And the economic model is based on membership and donation from a variety of different entities that includes a lot of academia, so the Ministry of Research in France, the National Center for Research in France, the National Archives in the Netherlands, then different universities, a couple two big universities in France, 2 universities in Italy, and I hope to see much more coming in the future. But also companies, IT users, etc., that see value in this kind of archive, which is an archive for us, but it is also a reference knowledge base for them. So if I want to finish this part, this was a call for action. What can we do now that we have this tool that comes from our community? Okay, it is developed by researchers that know software development for researchers who do software development. So it is actually an infrastructure done by us, for us, and the rest of user software. Well, what you can do, what we need to do now is to train people to actually use it, tell them it is available, explain them how to adopt it and use it. You know that academia is a slow-moving river, so it will take years, right? But we need to start, and we need to start today. There is also an issue of engaging with conferences, journal, learner society to have them use this infrastructure, which is adapted to software, which is not the case for the other they are using right today. For example, for Artifact Evaluation Committee, the availability of the source code should be connected to the archival there. And we need to help and grow and structure our community, because software actually is an infrastructure, but it is more than that. It has a possibility of opening connection with policymakers, and we'll go to this in the next phase. So it is important to include the use of software in the open science policies, and actually be part of this adventure. Becoming a member, becoming a sponsor is a way of contributing to the evolution of the project. That was a phase 1. You know, I have 5 minutes for phase 2, but I will try to do it. If I look at the broader policy issues, you remember what it was? Policies on dissemination and reuse. The question is, one reason why we do not find source code is that people do not share it. And why do they do not share it? Maybe because they think they cannot share it. So there is an issue here. I have a policy about opening up the source code of research software. It's a policy issue. So this means we also need to think better about the technology transfer industry collaboration we are developing. So it should not be first step, close it, then see, maybe if 10 years you can use it, and if you really cannot use it, then open it up. It doesn't work this way. You need to work the other way around. If you do not have a clear plan for technology transfer, the best you can do is you open it up today, because others will build on top of it, and you will have a bigger impact. Then you need a framework for evaluation and recognition of software development. Making software development count in a career. I mean, not whatever software development, right? I mean, quality research software development need to be evaluated the same way as we do for papers. But for example, if you take a case of some countries, I'm just mentioning mine, my original country, Italy, it counts for absolutely 0 in the career of a researcher. There is not even the line where you can say, I developed this piece of software. It is not part of it. France is slightly better, okay? So particularly in our fields, in computer science, we actually value software development, but it is not the case in all the fields. But when we do this, we should really try to avoid the number games that has polluted research in publication up to now. So I have seen people with goodwill that proposes very stupid ideas, like counting the number of commits. I mean, what is my contribution to a piece of software is the number of time I made a commit to a piece of software. Are you sure? It's like saying the number of contribution to a research paper is the number of time I edited the file. It's kind of a strange proxy for quality, right? And then the other point is counting the number of time a piece of software is used by other pieces of software. But this is a measure of popularity, not a measure of quality. So we have seen already all these disasters in publication, right? So let's try to avoid it in software up to now. And then there is an issue about sustainability. The technical sustainability of the project and financial sustainability of the software project that we develop and we reuse. And the point is that here for research software, the difficulty is that it is not as easy today to fund an important research software which is used by many colleagues as it is easy to buy a license for Acrobat Reader or Microsoft Word. Okay. It is much more complicated in terms of accounting, in terms of legal aspect, etc. So we need to simplify all this to actually have sustainability in research in the long term. So but there are good news. Here there are good news. So let me start with some of these good news. UNESCO has been tasked by the member states in 2018 to come up with a recommendation for open science. This recommendation of open science has taken 3 years to a multi-stakeholder discussion, and they have been finalized this year, and they will be voted by the General Conference that will take place next month. So we hope by the end of the year this will be published. And here I just selected a couple of parts that you see in this recommendation. One recommendation is about the relevance of open source software for open science. Okay? So opening up the source code of software which is needed for open science. You see, the source code must be included in the software release, made available, etc., etc. And then for infrastructures, there is another good news. Here they say open science infrastructure should be organized and financed upon an essentially not-for-profit and long-term vision which enhance open science practices and guarantee permanent and unrestricted access to all. I mean, there is a typo here, to all, to the largest possible extent. So these are general recommendations from the UNESCO conference that will come out in a month. At the European level, there is an initiative which is called EOSC, the European Open Science Cloud, that originally didn't include software, but now it does include also support for software. And here you will find this report that was written last year by an expert group that I co-chaired. And it is an important policy tool too. I mean, it contains a bunch of recommendations coming from actual infrastructure, real infrastructure that actually have to handle software every day. We brought together 3 archives, 3 open access publishers, and 3 aggregators. So we had this recommendation for infrastructure being open and non-profit. the use of software edge for an archive and the software edge identifier, the cryptographic identifier for tracing exactly the version, and this recommendation for defaulting to open source for research software. That is to say, research software should be open source unless there are reasons not to be, and not the other way around. But this is just a report. Now the probably more actionable part is the creation of the task force dedicated to infrastructure for quality research software in the years. This has been announced a few weeks ago. And the idea is to help here the development of this infrastructure for quality research software, increase recognition for software developers. So you see, things are actually moving. You see them written down. It is not just words. I mean, these are part of a strategy. And let me finish with the last, but I will consider probably with the most relevant document of all I have here. This is the English version that was just published a couple of weeks ago of the National Plan for Open Science of the French Ministry of Research. This is the second iteration because the first was in 2018. In this second plan, you have a full track dedicated to software, which was not present before. Now there is a track on data, a track on publication, a track on evaluation, and a track on software, which is a full-fledged one. And here between the actions, among the actions, there is a charter for research software policy. So in the next year, we will have groups working together to have a charter, a global charter in France for research, for a policy for research software. We have created a prize for recognizing remarkable landmark research software. This is not just for informatics, this is for all disciplines. The prize will be awarded by the Ministry of Research in Academy of Science on February 5th in France, in a beautiful place and beautiful framework. This is a way of telling people software is important in research. And then there is an issue about creating community, coordinating the activity and the ecosystem. And concrete recommendation here also, software heritage is a part of this strategy because we need an archive and we need a reference archive. So you can see the official announcement. I have 10 copies of the physical object that I can share with anybody that wants to have a copy. There are many other things, not just software, also about publication, about career evaluation of researcher, about open access, etc. It's really worth reading. So let me finish with the final call of action here. On the second part, I mean, policy issue, we really need to engage with policymakers. I know it is time-consuming, it is complex, it's not easy, but it is necessary, and it is our responsibility to do that. When I was younger, I was looking to my professors and the leading researchers in my field. Every time I saw something which was not good, I was telling them, hey, why don't you speak up? Why don't you go and talk to the politician, tell them what they should do? And now it happens, I am on the other part. I grew older. And so I had younger people telling me, why don't you go and do it? And we need to go, we need to do it. So what we need to have is, for example, to have an open source VP, vice president, in universities, in ministries, in governments. Okay? We have open science vice presidents, but this is very broad. What about software? Okay, we need people that are in charge of this. We need pushing for infrastructure for software. Infrastructure for software are different from infrastructure, for example, for physics. When we do big infrastructure for software, the major cost is human resources, not buying the computers. Because you buy a computer, you need to buy again in 4 years, okay, because the warranty expires. It's not there that you need to have money. You need to have the people, the engineers, the researchers. And typically infrastructure programs like the S3 European project are not designed for this. So we need to go and talk to these people and tell them, look, for infrastructure related to informatics, we need a different approach. And then we need to set the default to open. I mean, we really need to pass a message. The best thing we can do is that make sure the publicly funded research software should be made available as open source, unless there are reasons not to do it. There are cases where there is reason not to do it. And finally, for career evaluation and incentives, we really need to recognize quality software development here and there. So I added a couple of links about what we do in informatics in France. So if you look at INRIA, if you look at the Computer Science Institute in CNRS, there are criteria for self-assessment and evaluation on software contribution. They try to be adapted to our world. You are very welcome to pick them up, adapt them to your needs, or criticize them if you think they are not enough. But the final message for me is really try to keep the human in the loop. When we talk about careers and evaluation, the number game is dangerous. Okay, I know the politicians want them because numbers seem subjective, but there is nothing less objective than numbers in these kind of things. How can you count one for a software project like the Cork-proof system or the OCaml programming language or the Python language, etc., and one for a 10-line script which is attached to a publication? It is not 1 and 1. You cannot just sum numbers like this. You need intelligence in looking into these things. Well, sorry for taking more time than expected. It has been a kind of rough ride. But my final message is a message of optimism. It took a lot of time to get here and to see things starting to move. A lot of road is ahead of us, but I think that if we work together as a community, if we push forward these kind of messages, we can make it. So, sorry for the delay, and thank you for attention. I will stop here.
Thank you very much, Roberto. And the floor is open for questions, and so that they are transmitted to the remote viewers, I would ask Roberto to repeat the questions that are made here. So, any questions from the audience, please?
Marjan Medin from the University of Maribor, Slovenia. So I really do agree that the solver is one of the pillars of the open science. I'm working in the evolution computation, and I'm very suspicious when I'm reading papers claiming that this is the best algorithm without seeing this solver. And I have two questions. So you already talked a little bit about that. So the outcome of the research is solver. But sometimes out of the research, I'm going to also make a spin-off company. So when I should publish, when the solver should be open and when not, is one of the reasons when this should not be open source anymore. And can you also talk about the legal issues? So if I'm writing a solver for medicine, and this open source is used in some hospital working, and this is then going very, very badly, some fatalities. I'm responsible for that.
Thanks a lot for this question. We'll try to summarize it and repeat it for our remote attendees. So the question here about what is actually the right strategy for software that we produce. I mean, is it making it open source from the only way? There are situations where we shouldn't do it. For example, if we need to create a company out of this software we are producing, and also there is some kind of worries here about what are the legal responsibilities. If I make my software available and it is usually badly in some application, somebody uses it in a medical application, somebody dies, what are the liability and responsibility in that particular case? So this brings us to two different questions. One is legal, and the other is actually technology transfer. First of all, I would encourage all of you to go and check in your country, because this depends on the country and depends on the institution, who is actually the right owner of the software that you write. Because, you know, as an author of a piece of software, I'm an owner of my moral rights, so nobody can strip me of the fact that I am the author. But the decision of open sourcing it or making it closed and selling it for a license is not necessarily mine. It may be my employer's decision. It depends on your university, on your country, on the legal provision in copyright law in your particular situation. So you should check. So sometimes, to answer your question, it is not up to you to make the decision. It is up to the right owners. That could not be you. But let's suppose it's you. Okay. Then there is a question of how do you can have technology transfer if you have open source? Well, of course, if you start the software development in the framework of a collaboration of with a company, then from the beginning you are probably prevented from open sourcing it because it is part of the contract, of the collaboration contract. If you are just thinking about creating a startup later on, then maybe your experience may be different from mine and that of many colleagues of mine. If I look in the last 20 years, what I know, what I heard, etc., in general, there are very rare cases where you can take a research project outcome, I mean the software produced during research, package it up and sell it with a license and that's it, and it works. There are some cases where it works, but in most of the cases, this is not the way you do the technology transfer. The way you do the technology transfer is that you create the company or your students go to the company and work there, because just the source code alone is not enough. You need the people that has the knowledge to do this. And so having open source at the beginning is not necessarily going to hinder your opportunities for creating a company. Because again, it is a case-by-case analysis. It can be the case that having a lot of people using this software is actually creating for you a demand for support, a demand for use, etc. So you need to balance these kind of things. It's not automatic that creating open source is preventing you from creating a business. Actually, if you look in France, we made analysis of the business around open source. The last result is 6 billion euros last year was the business generated around open source only, which is more than 10% of the global value. And there is a study of the European Commission about the impact of open source in Europe, which is between 60 and 90 billion euros a year. So again, it is a case-by-case analysis, and it is up to you to do it. But I agree there is a tension here between the need of open science, where I need to be able to reproduce what you do and check what you do, and potentially the need of creating a company aside. And that's the reason why we need to have a charter where we discuss all these issues and try to set some lines, ground lines on what to do. Then about liabilities, that's another complex story, because if you see what people tend to do when you distribute software under an open source license, you're actually disclaiming liability. You say this is as is, available as is, and you do what you want. Then again, it depends on your country. There are countries where this kind of disclaimer is not acceptable, and you are responsible. So sorry, it is not an easy answer because it was not an easy question, but it is a complex issue that we need to handle together.
Yes, Ivica Cikovic from Chalmers University. So thank you very much for the presentation, and also it reminds me when you showed from your software heritage code from Apollo 8, and when I saw it, I was it's kind of cultural heritage. It's really special feelings when you look at it. And that's maybe related to that question, the value of source code. You know, in many cases, you see the source code, but you actually cannot reproduce it in machine code because you don't have tool. That's one thing. The other thing is that maybe you have source code, maybe even tools, but you don't have data. And you know now some sources even created based on data. So according to your understanding, is really the source code, is it the most important to archive, or should everything be archived in the sense that you can reproduce? But that's very challenging.
Absolutely.
So maybe this relation, if you can.
Yeah, okay, so let me repeat the question. So I can try to summarize it this way. So yes, source code is very important, but what about all the rest? If you are really looking for the holy grail, which is full reproducibility, we should actually archive everything and keep everything at hand to be able to actually rerun, reproduce experiments. And now, so my answer to this comment is I fully agree. So what we do in Software Edge, we are just handling one part of this mission, the source code, because nobody else was doing it, which was surprising, right? You have initiatives that try to keep running machines, like virtual machines or something like this, different kind of technology, and the jury is pretty out there to see what is the best way of keeping reproducibility, or emulators, or this kind of thing. Many initiatives in that space. So we didn't want to overstep. We want to collaborate with others working in that particular case. But the observation we made is that actually source code is something you have seen, something you can actually read. Well, if you only have a binary, and you no longer have the machines or the information on how to run it, there is not much that you can do. And keeping machines running and full reproducibility is really an extremely complex technology issue today. Even multi-billion-dollar companies have difficulty in doing this. You see, when you have shortage or outages, that you made a mistake in moving from a test infrastructure to the real infrastructure. This is the same as reproducibility, right? I mean, reproducibility is an extremely complicated issue. So I absolutely do not pretend the Software Edge is going to solve this. I say this is a piece of the part, and it's a particularly interesting piece of the part because in the source code you have part of the history of what we did. You can find what was in the brain of people writing this code back then, and you can still appreciate it, read it, understand it, and study it, even if the machine is no longer there, and if you cannot run it any longer. And by the way, if I can piggyback on your question with an extra point, there is something that I didn't mention at all, but another initiative we have with UNESCO is to launch an initiative to actually go out and look in the old drawers, in the old boxes, and find out all the relevant key software that has been developed decades ago in our university, in our institution, different companies, that is extremely valuable, and make it available again, archive it in a software heritage. We did this with the University of Pisa 2 years ago, and there is a protocol with UNESCO for doing this properly. And we are working on an extra step to actually present this together with videos, images, interviews, books, articles, because they are an incredible part of our story we still remember, because in our discipline, we have a privilege. We can still talk to the people that created all this, while my friends in astrophysics or in physics or in chemistry or biology, they have no way of going back and talking to Kepler or talking to Newton. We can still do it for a few years, so we should move forward quickly. I hope this provides an answer to your question.
My name is Paul Roberto from the University of Bucharest. I've been a very active member of the open source community, doing the kernel work, OpenBSD, Linux, and other open source communities, large communities. And I think your talk was right on track with what the open source community that I know wants and does. But from an academic point of view, I don't know if it's the same everywhere in Europe, but for example, my government promotes open science. They give funds to academics, universities, to means to publish articles that are open. But they don't really know what open is because they're government, they don't do science. But what happens is that there are, well, I don't know how to say it nicely, but they're like journals that take advantage of this, like IEEE Access or NDPI and stuff like that, and they say that's open science, which I disagree with, coming from the background of open source, which is, I think, very similar to yours, and which is just a way of making money, but not a way of doing reproducible research or doing anything science related, really. So, how do you deal with that confusion when you deal with policymakers or with actually other people among other peers? Because colleagues of mine, I mean, you know, if they don't do science part or something like that, they say, okay, my article is open, that I'm doing open science, and I disagree with that. So how do you settle that?
So again, let me try to sum up this comment. So this remark that asked for comment is about some confusion and some misguided actions that we have seen with open science. So the push towards open science is making the result of research open to everybody. But if you go back in particular to the open access story, you remember the long, painful story to open access, one way of making this research open is to actually pay for some kind of article processing fees, which are set in an arbitrary way by any particular journal. You know about predatory journals or others. Well, I can repeat it. This is part of the question. If you know IEEE access, which is in principle open access, but then you need to pay a hefty amount of money to have your paper published there, and then the review process is extremely short. So you get the impression, I do not know them, so I will not vouch about this, but you get the impression this is more a business than a service to our community. And so the question was, how do we deal with this? So let me say, what actually motivated me to spend a significant part of my time in this policy action is that I finally see policymakers that can listen and that can rely on counselors that are knowledgeable. So for example, in France, you have this National Committee for Open Science, that was created as a consequence of the Open Governance Partnership engagement that were taken in 2016. And here you have people who are actually looking at what you say. I mean, how can we fund properly open science, but in such a way that we are not creating just a parasitic business? We are actually pouring money into common infrastructure that are at the service of the community. So in this plan, I will give it to you. For example, there are provisions to fund and support diamond open access journals and to support quality reviews in that particular case, open and quality reviews. I don't know if this is a part of the answer to what you asked, but you see, there is a window of opportunity now where at the political level people want open science, and if you take the time, do the effort, and find colleagues and allies, you can push the real message. And on my personal side, if you look at what we do in software heritage, for example, a couple of seconds, because this is important. You see, when you're building infrastructure, and for example, journals are infrastructure for research, are virtual infrastructure, but when you're building infrastructure like software heritage, there are basically two ways of building infrastructure from an economic point of view. Depends on what you want. If you want to buy a Ferrari, there is a way. And if you want to advance at the common good, that's another way in general. I'm not judging anybody. I like Ferraris. If you have a Ferrari, I will be more than happy to have a tour on it. But if you want to have a Ferrari, what you do, and this is not me, it's Bill Gates many years ago that just said it, what you need to do is to set up an infrastructure that has a fixed cost and a variable revenue stream. Look at traditional telecom companies, okay? Setting up the telecommunication network is very expensive, but it's a fixed cost. Once you have the communication network in place, if nobody uses it or everybody uses it, doesn't change a lot, the cost of the infrastructure. And then you can sell subscriptions with different plans. You have a plan with 10 SMS for free, and then you pay €1 per SMS. Or you have 1,000 SMS, but then you pay for this. You know this? You have seen in your life. This way, you just sit down, you become very rich. If you look at one of the richest person in the planet is Carlos Slim, and it is based on this kind of approach. Okay, use this infrastructure to get a lot of money. So the economy of scale goes to the stakeholders, to the shareholders. Okay. The other approach is mutualizing the cost of the common infrastructure. That is to say, you have a cost, you probably multiply by 2 or 3 because you never know, but then you have this cost, and then you divide the cost between all the users. So the more users you have, and the less it costs to all the users. So this is mutualization, so the economy scale goes to the stakeholders and not to the shareholders. Now I think governments and politicians, some of them at least, are starting to understand the difference between these two approaches. And I believe that what we need in the open science space is more emphasis on this mutualization effort instead of the privatization of profit approach. Which, again, I have no judgment of value here. It is just our interest as a community is to go the mutualization way. I hope this answers your question a bit.
Sure, thank you.
Thank you.
More questions? Yeah.
It's very valuable initiative and important. But I wonder actually if this is so different from the issues in open data, because I mean, this open data movement, as you mentioned, is fair. It's actually a lot about this setting up the contractual and like infrastructure basis for sharing data, and findable, accessible, interoperable, reusable. And actually, much of what you were saying is also along this direction. And particularly if you talk about source code, it's like somehow like a stationary, the source code is a stationary object, so it's not so far from data as kind of an entity. So I'm just wondering, because there is so much momentum on this open science and open data. I know it's a good opportunity to piggyback on that. And I know that it's also these open data communities, like this RDA, the Research Data Alliance, they are thinking a lot about extending this collaboration towards also covering tools and so on, and code. So I wonder if you have some like connections to this open data communities. And since I had also two additional points, so I very much like the idea of having a VP for. Well, I wish we had a VP of even open science, I think, not to mention open source. I'm not sure that you said every university has a VP for open science. I'm sadly suspect that this is not true. And the other idea that comes to mind, so I mean, in the area of publication data, these DOIs are a very kind of a valuable innovation and tool. So is there something, would there be use of something analogous for code or interaction or something for code?
Very, very good point. So to repeat the question, so the question was about the connection about the open data with the open data movement, where there is a strong traction today, in particular in organizing international fora like the RDA, which is the Research Data Alliance, and could we piggyback on that movement to actually push forward our agenda about software? So just to be very transparent, I created the source code interest group in RDA in 2016 there. So I already made some effort to go there and try to see. I did not necessarily find there the kind of knowledgeable people I find in this room, because they are very much more focused on data than on software. And it takes a lot of time to work with them. But yes, we must do our homework and be connected with all potential partners that we have. But then maybe if I can take a second here to, what is this is Edge, or what is that? No, what is this? I didn't want to do that. Whatever, how do I get out of this stuff? I don't know. Well, I wanted to go and show you actually the archive internally, how it is, because I skipped the demo section, and it's a pity. I mean, there is a huge difference between how you treat a source code, how you handle source code, and how you handle a generic piece of data somewhere. So when you do fair, findable, accessible, interoperable, reusable, the big issue, I mean, let's forget all this. The big issue when you are handling research data is there is a lot of confusion there. So you can get, for example, a comma-separated value file with tons of strings or numbers, etc. You don't know what it is, which is bad practice, right? You should at least have the column names that tell you what is in each of the columns of this data. So you should have some documentation that tells you what is this, from what instrument this data was produced, etc. And so when you look at this FAIR movement, it is really a lot about this. I mean, convincing people that you need to equip your data with metadata, which follows a decent vocabulary in such a way that another researcher in another team can reuse it. Because if you just get this raw data like this, what can I do? So the big focus is on metadata. Or accessibility, for example, I don't have this data, who should I ask to get a copy of this physical data, etc., etc. It's a pretty valuable goal, and it's very cool, okay, and we need to do it. But is this really what we need for source code? Because when you get the source code of a project, usually, if it is not just a student project, what you get is a README file that tells you what the project does. You have a dependency file that tells what you depend on. You have a make file that tells you how to compile it. You have a lot of information already inside it. So I'm not sure the big issue is about all this equipping with extra metadata, vocabulary, etc. It's another issue, is how to make it sustainable, how to choose the right license, how to actually transfer it to another product, etc. There are different issues from the one that you have in data. So yes, we need to work with them, but let's not confuse, let's not mix up the objectives. And about the second part you raised, they use DOI, the Digital Object Identifiers, which are very popular in the publishing area. Now they are being used for data too. We do not use this kind of stuff in software Azure because we use intrinsic identifier, which is the way software development started to be done 15 years ago. Okay, so we need to have the ability, if I'm in Paris and you are in Oslo or whatever, and we are working on the same piece of software, we need to be able to check that we are on exactly the same version without relying on anybody else. And I can do it very trivially using Git today. I say I'm commit 0x367AF2. You check it locally, you are on the same commit. You do not need any register or reference or whatsoever. And the registers can be changed, as you know, while the cryptographic hashes cannot. So DOIs are useful for other things, for tracking the name of the project, for example, but not for the source code itself. So, and again, I think it is very important to work together with others, but never forget about what makes us special here.
More questions? So I actually have a question.
You know how to get out of there?
You try this, maybe Control L does something.
Fantastic. Okay.
You want to connect to server heritage?
No, let me go ahead.
Okay. My question is, in the list of supporters, there were names like Microsoft, which now sort of embraces open source, but also Huawei, which I'm not sure if they embrace open source a lot. So my question is, apart from supporting, have these private companies currently contributed with software-to-software heritage with source code?
Very good question. So the point is, if you look at the different company and partners that actually are supporting software Azure, they are providing funds to have the infrastructure run, and all of these companies actually use open source massively. So this is already the case at Microsoft, it is the case at Huawei, it is the case at Société Générale, which is a bank, it is the case at Intel, etc. The question you are asking here, and I repeat it for the remote attendees, is, okay, so they provide you with funds to support archiving of open source, but do they also contribute as open source part of their software to the archive? That's a very different question, because you need to ask them, are you ready to open up part of your software? Now, the surprising answer is that yes, they are actually opening up quite a lot of software components. So Microsoft is contributing tons of open source to not Windows and not Word and not PowerPoint, of course, but many other software components are open source. The same is the case for Huawei, and the same is the case for Société Générale, but not all of their software stack. Part of their software stack are already open and archived today.
Any other question? Well, then I think we can thank the speaker. Thank you, Roberto.
Thank you.
And well, this is the end of this session, and I just want to take this opportunity to tell you that Informatics Europe is planning to open a working group on open science and open publishing. So this will be more officially announced in the coming sessions or coming time. So if you're interested in being part of this working group, studying how open science impacts the academic world, so well, you are welcome to join that working group.